Hello everyone, welcome back to Chemical Engineering and Aspen channel. As you know, these days we are focusing on the module of Chemical Reaction Engineering. So in this regard, we are bringing the lecture number 29 for our valuable viewers. So in today's lecture, we will start with second order reaction in PBR and we will do its derivation. It will be a very short lecture to understand how the things go in PBR and then we will solve its numerical in the next lecture. So we say that A goes to B or A converts to B in an irreversible manner. Accordingly, once we apply our algorithm of mole balance, we say that Fa naught dx over dw is equal to minus Ra prime. We say that for PBR it is minus Ra prime, while the units are mole per weight of catalyst per time, while that of the other cases like PFR or batch or CSTR, we say it as minus Ra and the units are mole per volume per time. Applying the rate law, we say minus Ra prime is equal to Kca square. Obviously, you can now see that it is not an elementary system, it is a non-elementary system because we say a system as elementary if the coefficient of the reactant is same as that of the exponent in the rate law. Here it is 2, here it is 1. Applying the stoichiometry concept for isothermal operation, and we say that epsilon is equal to 0 because epsilon is dependent on sigma and y naught. Obviously, y naught is there, but sigma is moles of product minus moles of reactor. So 1 minus 1 is obviously 0. So accordingly, epsilon is 0. And we say C of A is equal to F of A over small v. Now that F is the molar flow rate, that V is the volumetric flow rate. Now that F is converted as Fa naught into 1 minus X. And that V is V naught into 1 plus epsilon X P naught over P. Now we are not ignoring the pressure drop, we are considering it in the system. But since it's an isothermal system, so we are ignoring P over P naught term. So that Fa naught over V naught will goes to Ca naught. 1 minus X, epsilon is 0, so that term is also vanishes. That P naught over P goes to P over P naught, and that P over P naught goes to small p. So that term goes to Ca is equal to Ca naught into 1 minus X into small p, and that small p is actually P, which is the outlet pressure, over P naught, which is the inlet pressure. Now we know P is equal to P over P naught, and that is equal to square root of 1 minus alpha into W. Accordingly, substituting the value of P here, that Ca is equal to Ca naught 1 minus xp, and that P is square root of 1 minus alpha into W, while that Ca naught 1 into 1 minus x will remain the same. Combining this, we say dx over dw is equal to minus Ra prime over Fa naught. Minus Ra prime is Kca square, while Ca is Ca naught into 1 minus x square root of 1 minus alpha W. Now that whole square means that K Ca naught square 1 minus x whole square into 1 minus alpha W, because that square root is cancelled out with this square, over V naught C naught, because F is small v into C naught. V is the volumetric flow rate, C is the concentration. Accordingly, that C naught is cancelled out with this C naught. We get K C naught 1 minus x whole square over 1 minus alpha W over V naught, and that is dx over dw. Going to the evaluation part, once we rearrange it, we get V naught over Kca naught. If we take you back, that we are rearranging this equation, dx over dw is equal to Kca naught over V naught. That V naught over Kca naught will go here, 1 minus x square will go here, while dw will come here. And that is represented here, V naught over Kca naught. These are the constant terms, so this will come out from the integral 0 to x dx over 1 minus x whole square. And that is equal to integral 0 to w 1 minus alpha w into dw. Now once we integrate it, we get this expression result. This will come out as x over 1 minus x, while this will come out as w into 1 minus alpha w over 2. Now if we rearrange it for x, obviously it's a mathematical step, so you have to take paper and pen and you have to solve it. So you get x is equal to Kca naught w over v naught into 1 minus alpha w over 2 divided by 1 plus Kca naught w over v naught into 1 minus alpha w over 2. And if you want to solve it for w, you get w is equal to 1 minus bracket 1 minus 2 v V naught alpha over k C A naught into x over 1 minus x whole raised to power 1 by 2 or square root divided by alpha. So that is the overall derivation for the second order system, second order reaction, which is occurring in PBR, and we have derived two expressions that we want to see if we know the value of W here, because you see K is a constant term, CA naught is a constant term, V naught is a constant term. But if we vary the W, effect of W on X can be seen. And on the opposite, if we know the X, we can see how much W or the weight of catalyst is required for this second order system. So that is the derivation part, which I have for which I have separately prepared a video so that all the concepts can be revised before we can go to this numerical and the last part of this chapter. So that's it from today's lecture. Thank you so much. Please do watch, like, share the video and subscribe to the channel. Also click on the bell icon to get all updates related to this channel. Till then, it's goodbye. Stay tuned for more exciting videos on this channel.